Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture we are going to learn about the formation of molecular orbital energy level diagram for homoatomic oxygen molecule. So in the previous lecture we already learned about the formation of molecular orbital energy level diagram for nitrogen molecule. The link of that video is given in the card. Kindly watch this video also. Now here, if you are following all my videos, now we have studied the limitations of the valence bond theory. Now one of the limitations of the valence bond theory is found to be that oxygen is diamagnetic in nature according to the valence bond theory. But experimentally it is found that the oxygen molecule is paramagnetic in nature. And now by using this molecular orbital theory concept, you will know that why the oxygen molecule is paramagnetic in nature. So I request you to kindly watch this video till the end. Now from the previous few lectures we are discussing the formation of homoatomic molecule by using molecular orbital theory concept. Now there we have studied the 7 to 8 important key points by which we can easily explain the formation of these molecules. So in today's lecture we are also going to use a simple 8 point by which we are going to explain the formation of oxygen molecule, or it is also called as a dioxygen molecule, and the few properties of this oxygen molecule. So now the point number first, that is the oxygen molecule. You know that the oxygen molecule is formed by the two oxygen atom, and each oxygen atom contain the 8 electrons in 1s, 2s and 2p atomic orbitals. Now here I have shown the electronic configuration for oxygen molecule. We know that oxygen atomic number 8 and its electronic configuration will be 1s2, 2s2 and 2p4. Now the point number 2, that is the calculation of total electrons in oxygen molecule. The oxygen molecule is formed by the two oxygen atom and each oxygen atom contain the 8 electron. Hence the oxygen molecule will contain total 16 electrons that I have shown here. So now the point number 3, that is the construction of molecular orbital energy level diagram. The linear combination of two 1s, two 2s and the two 2p atomic orbitals of both oxygen atom gives the 10 molecular orbitals. Out of that 10 molecular orbitals, the 5 are the bonding molecular orbitals, and these are sigma 1s, sigma 2s, then sigma 2pz, pi 2px and pi 2py, while the remaining 5 are the antibonding molecular orbitals, and these are sigma star 1s, sigma star 2s, then the pi star 2px, pi star 2py and sigma star 2pz. These 10 molecular orbitals are arranged from lower energy to higher energy level as I have shown in this diagrammatic representation. So here total 16 electrons are distributed in these 10 molecular orbitals by following Abbott's principle, Pauli's exclusion principle and Hund's rule. So these 16 electrons are distributed as the first 2 electron will enter into the sigma 1s bonding molecular orbital, then the next 2 will enter into the sigma star 1s antibonding molecular orbital, then the next 2 will enter into the sigma 2s bonding molecular orbital, then the next 2 will enter into the sigma star 2s antibonding molecular orbital. So out of 16, the 8 electrons are distributed in such manner. Then the next 2 electron will enter into the sigma 2pz bonding molecular orbital. So here total 10 electrons are distributed, only 6 is remaining. So out of 6, the first 4 electron will enter into the pi 2px and pi 2py bonding molecular orbital, while remaining only 2 electrons. The first electron will enter into the pi star 2px and then last electron will enter into the pi star 2py anti-bonding molecular orbital. So here total 16 electrons are distributed according to the different energy level of the molecular orbitals, which leads to the formation of molecular orbital energy level diagram for oxygen molecule. So now let us discuss about the point number 4, that is the electronic configuration of dioxygen molecule. Now here I have shown the electronic configuration for oxygen molecule. You can observe that Kk is a constant, then sigma 1s2, then sigma star 1s2, then sigma 2s2, then sigma star 2s2, then the sigma 2pz2, the pi 2px2, pi 2py2, and then the pi star 2px1 and pi star 2py1. So this is the electronic configuration for oxygen molecule. Now while writing this electronic configuration, I have taken the reference of the construction of the molecular orbital energy level diagram that you can observe here. We have already distributed the 16 electron in the different molecular orbitals. Now according to the energy level, I have simply written the electronic configuration for oxygen molecule. So this is your point number 4. The point number 5th, that is the bond order. The bond order can be calculated by using the formula bond order equals to 1 by 2 into Nb minus Na, where Nb is the total number of electrons in the bonding molecular orbital, while Na is the total number of electrons in the anti-bonding molecular orbitals. So here for oxygen molecule, we can observe that the total electrons in the bonding molecular orbital is equals to 10, that is the value of a Nb equals to 10, while the total number of electrons in the anti-bonding molecular orbital equals to 6, that is the value of a Na will be equals to 6. So by putting this value into the formula, bond order equals to 1 by 2 into 10 minus 6, therefore bond order equals to 1 by 2 into 4, and the final calculations, the bond order comes to be plus 2. So these two oxygen atoms can connected each other by the double bond. So that is our point number 5th. Now the point number 6, that is the stability of molecule. So here the total number of electrons in the bonding molecular orbital is greater than the total number of electrons in the anti-bonding molecular orbitals, as we know that the value of a Nb is a 10, while the value of a Na is just a 6. Hence the value of a Nb is greater than the Na, and we already calculated the bond order, and bond order having the higher positive value, hence the oxygen molecule will be the stable molecule. So this is our point number 6. The point number 7, number of bonds, bond length and the bond dissociation energy. So here you can observe that the number of bond for oxygen molecule is at 10. The bond length for oxygen molecule is 120.7 picometer, and the bond dissociation energy for oxygen molecule is 498.4 kilojoule per mole. Last point, that is the point number 8, magnetic property. Now here we can observe that there is a 2 unpaired electron in the pi star 2px and pi star 2py anti-bonding molecular orbital. Hence the oxygen molecule is paramagnetic in nature. So just now at the starting of the video, there we have said that the oxygen molecule must be diamagnetic in nature, but experimentally it is found to be paramagnetic in nature. So your molecular orbital theory proves that the oxygen molecule is a paramagnetic in nature. So these are the simple 8 points by which you can simply explain the formation of oxygen molecule by using molecular orbital theory concept. Thank you so much for watching this video. See you in my next video.